First, let me explain of what apparatus, technique, and reagent are. Laboratory apparatus are the physical tools or instruments used in the laboratory to perform experiment and chemical procedure. The purpose is to facilitate multiple operations such as measurement, holding, heating, mixing, and analyzing chemical. For example, the measuring equipment are the burette, pipette, and measuring cylinder. Bunsen burner, hot plate, and crucible are utilized for heating. Containers such as test tube, beaker, and conical flask are also needed in most laboratories. Second, laboratory technique are common methods or procedure conducted in the laboratory with the objective of achieving certain things. It ensures experimental results, safety, and repeatability. For example, filtration is used to separate solid from liquid, while titration helps to measure the concentration of a solution. Crystallization is used to refine solid material. Lastly, chemical reagents are substances that are added to a chemical system in order to cause a reaction or to test if any substance exists. They are utilized for identification of unknown, initiating or maintaining chemical reaction, and illustrating changes like pH or color changes. Some examples of general reaction are acid and bases like hydrochloric acid and sodium hydroxide, indicators like phenolphthalein and methyl orange, and oxidizing agents like potassium permanganate. So, why this topic is important in chemistry? Laboratory equipment, technique, and reagent are the foundation of experimental chemistry. Without this data, things may be done incorrectly or even become dangerous. This topic also supports theoretical education since it enables students to correlate what they have studied with actual lab procedure. Besides, it requires accuracy and safety because understanding how to utilize equipment in the right manner, like how to heat a substance or use a burette, can prevent error and accident in performing experiment. In addition, these basics require develop essential scientific skills like critical thinking, correct measurement, and accurate recording of results.
Now, let's move to the next part, which is the types of apparatus, common lab tools. The first one, we have a glass round lab beaker as the function, holding, mixing, and heating liquids, and for performing chemical reactions. For the safety itself, we have to support the base of flasks and beakers when handling, especially when they contain liquids to prevent cracking. Burette function, precise dispensing and measurements of liquid volumes, particularly in titration. For the safety, check for air bubbles in the burette, especially near the stop cock, as they can affect the accuracy of the titration. In addition, for the common lab tools, we have test tube function, holding, mixing, heating, and observing chemical reactions and biological samples. As for the safety, we can avoid touching the hot test tube directly. Use a test tube holder or clamp to prevent burns. Last but not least, for the common lab tools is funnel function, a device or concept that directs something like liquids, data, or users through a narrowing path, often with the goal of achieving a specific outcome. For the safety, always firmly hold the stopper when shaking and regularly vent the funnel by opening the stop cock.
So there are 4 common lab techniques, which is titration, filtration, distillation, and recrystallization. The first one is titration. It is to determine the concentration of an unknown solution by reacting it with a solution of known concentration. The second one is filtration. It is to separate solids from liquid in a mixture. The third one is distillation. Distillation is to separate components of a liquid mixture based on difference in boiling points. And the last one is recrystallization. It is to purify solid compounds. Then, step for titration is, we have to fill the burette with titrant and then pipette the analyte and add the indicator. Add titrant slowly and swirl. Stop at color change and record the reading. For common errors to avoid for titration is parallax error. We must read it at an eye level. And then overshooting endpoint. And lastly is using the thick or wrong rinse equipment. For filtration, the step is, we need to place the filter funnel in the funnel and then pour mixture slowly. And lastly, we need to collect the liquid filtrate. Common errors to avoid in filtration is tearing the filter paper, splashing it, and touching inside a filter or funnel. Next, step for distillation is, the first one we need to set up the apparatus. Second one is heat it gently and collect liquid that boils off. Common errors to avoid is heating too fast, poor condenser cooling, and leaks in setup. Step for recrystallization is the first one. We need to dissolve the solid in hot solvent. Next, we need to filter the solution and let it cool slowly to form a crystals. Filter, wash and dry the crystals. Common errors that need to avoid is too much solvent and it will form a poor crystallization. Next, cooling it too fast, it will form impure crystals. And lastly, not filtering hot solution.
Right, so what are reagents? Reagents are chemicals that we use in experiments. We can use them to start a chemical reaction or to check if a certain substance is present in a solution. Sometimes, we also use reagents to measure the properties of something. For example, to find out if it's acidic, sweet, or if it contains sugar. So here are some easy examples. Hydrochloric acid or HCl is used in titration and acidity test. Benedict solution is used to test for reducing sugar like glucose in food. So here is a sum of role of reagents in chemical reactions. Reagents play a really important role in chemical reactions. They help us in a few ways. First, they help detect and measure substances. For example, using Benedict solution to see if a drink contains sugar. Second, they are used in analytical work. That means we use reagents to get accurate and detailed results. For example, using hydrochloric acid in titration to find the exact concentration of a base. Third, reagents help us standardize solutions. This means we prepare solution with a very exact concentration to use as a reference, like using sodium carbonate as a standard in titration. Lastly, some reagents have specific use for special experiments. For example, special solvent used in spectroscopy or HPLC to help separate and identify chemicals. So how do we choose the right reagents? First, we need to be careful and make sure we pick the correct one for our experiments. Number 1, always choose the most suitable grade, especially for analytical work. This is important so we can get accurate and reliable results. Number 2, if you are preparing a standard solution, make sure to use primary standard grade or analytical reagent, AR grade. This type is very pure and give precise measurements. And number 3, try to pick the smallest bottle size. This helps us avoid wasting chemicals and also prevents them from expiring before we finish using them. When we handle chemical reactions, we must always follow these safety rules. First, always close the reagent bottle straight away after using it. This is to stop the chemical from being exposed to air or from evaporating. Next, always hold the bottle stopper between your fingers. Don't ever put it on the table. This is to avoid contamination. Contamination means something dirty or unwanted gets mixed with the chemicals. And finally, never return any extra reagent back into the original bottle. This is to keep the reagent pure and safe for other people to use later.
To summarize, understanding a laboratory apparatus, techniques, and reagent is essential for anyone involved in analytical or experimental chemistry. These elements are the basics of practical scientific work, connecting theoretical knowledge to hands-on practice. Each apparatus, like beakers, pipettes, and test tubes, has a specific function and must be used with proper safety measures. Mastering common lab techniques such as titration, filtration, distillation, and recrystallization helps ensure accuracy and reliability in results. Proper usage and awareness of carbon mistake are the key to avoid experimental errors. Meanwhile, reagents play a crucial role in driving chemical reactions, and selecting and handling them correctly is important for safety in a successful experiment. Together, these components develop essential scientific skills and promote responsible laboratory practices. Why are these essential for laboratory works? From what we have discussed in this video, apparatus techniques and reagents are essential for laboratory works to help you do the experiments properly and safely. Thus, ensure that your results are reliable and accurate for future reference, while building your skills in science and allow you to understand how chemical works in real life. That's all from us about apparatus techniques and reagents. Thank you for watching and listening.